Yeah, we definitely covered the CardioBot. There are two versions of it. Yes, they're not really duplicated. The CardioBot is more advanced. The CardioQuest is more basic. Yeah, this one will work. This one just teaches you about the hits, false alarm, correct rejections, and misses. You can find abnormal ECG patterns, avoid clicking on normal ECG, so you gain points, and it will do the, what's the table called? Yeah, there's hundreds of different ways of calling this stuff. We could actually, now that I'm thinking, yeah, that's a normal one, so I'm not clicking on it. Once it's passed, I'm getting 10 points as well. This one is abnormal, and then if I miss an abnormal one, misses go up. This should happen again because I didn't click on it. If I do click on it, it's a hit. Every 50 points, the speed goes up as well. And a false alarm is when we have a normal one and I actually click on it. So that was a false detection. So my false alarm count went up. And yes, there is a, when it goes below 50, it will go slower again, giving you, longer window of opportunity to get it right. I think the rate between normal and abnormal is actually 60-40. So you could, just by not clicking, gain some points maybe, or maybe it's 60-40 the other way around. So 60% abnormal that you do have to click on. Yeah, that makes more sense. So then the number of points will gradually go down if you don't actually interact with the application. Now that I'm thinking about it, we could actually add a ROC curve to it, modified on the fly. That would actually be quite good, wouldn't it? So we can have another version of it. We do have another version where we apply fuzzy logic analysis. So this one is essentially the same thing, but more advanced. It has, you can reduce noise level and see how essentially an explainable AI algorithm performs. It's a fuzzy logic algorithm. You can see what it's doing at the bottom here. So it's essentially looking at the number of positive peaks. So you can see when the noise is increased, it's giving you 35, and it's really sending the algorithm into la la land, and it cannot perform. The performance is, so it's giving you abnormality score, and the performance is being calculated. So the machine is still doing quite well, even with increased noise. Well, it did do false detection, so it's essentially more likely to say the waveform is not normal. Every time I say abnormal, the speech to text, the transcriber, even Google ones that meant to be really good, is stuffing the text up. Yeah, if you reduce the noise, then those false alarms should go away. It's actually that slow at the moment because the human score is -50, so it's giving a human a better chance to actually start performing again. Yeah, the main advantage of the machine is that it can make a decision in fractions of a nanosecond speed, whereas a human takes more time. So I was saying before, we might have, just build upon this and have a third version that also has a ROC curve being plotted as you play the game. How hard would that be? You reckon? Yeah, we probably should go from the simpler version of it. Yeah, obviously that will be better. So essentially the idea is that you will have a ROC curve chart on the side